All right, so for this first topic video, as promised, we're going to redefine what logarithms are. It will be a repeat of what we did in class today, but I do want you to at least kind of skim through this video, make sure you've formally written down this definition in your notes, and then you can hop on to the next video. And certainly if you weren't in class today, this would be a good video to catch a few of the details that we talked about during class. So take a look at our canvas here. In one moment. And I'm going to write down for us just a typical, I'll say y equals b to the x. So this is a typical example of an exponential expression. Really as simple as an exponential expression can get. And what we said in class today is that we need a way to be able to reverse the operation of exponential functions so that we can solve for variables like x here if we had a situation like when is 2 to the x going to equal 100, for instance. And up until this point, all we've been able to do is just guess and check the value of that x variable, and kind of, if we keep guessing, eventually we could probably get to a reasonable, rounded answer. But we need something, we've said in class before, anytime you're doing guess and check in mathematics, it's probably a good hint that there's a better way to do this. So the reverse operation is what we call logarithms. And a logarithm says that I can rewrite any exponential equation in terms of a logarithm by saying log base b. So we call this the base when we have an exponent because it's the value that holds up the exponent. But we also call it a base in the logarithm, and we write it with a subscript, log base b of y, in other words, the output of this function, equals x. So any expression y equals b to the x can be rewritten as a logarithm or in logarithmic form as log base b, so both base b of y equals x. And one of the important definitions that I gave you in class is I said a logarithm always outputs an exponent. So a logarithm, I should say a logarithm always outputs an exponent. Can fit it all in there. All right. And logarithm always outputs an exponent, keyword being exponent. So in this case, log base b of y equals x. The value of a logarithm always outputs, or on the other side of that equal sign, is an exponent. So if I have a button on my calculator, which we do, and we're going to learn how to use that in class tomorrow. I'm not going to talk about that specifically in the video, although we're going to work up to it today in topic 2. But log base b of y, that's something we can calculate using a calculator, and we can get an exact value for an exponent. So in this case up here, if I had 100 equals 2 to the x, when does 2 to the x equal 100? I would be able to rearrange it, plug it into our calculator, and find the exact value of that exponent without having to guess and check. So that, in its most basic explanation, that's what a logarithm is, and that's what a logarithm does. So the definition of a logarithm, I don't know if I can say a definition, but a good working definition at least, is that a logarithm always outputs an exponent. And then I also said in class, a logarithm in fact is an exponent. So if you want to write that down, a logarithm actually is an exponent. And we'll talk more about why that's important. Whoops, exponent. We'll talk more about how important that is as a definition of logarithms in the next topic video. So make sure you have that written down. That's just a review of the highlights of class today, and then get ready for some new information in topic 2.